So we are all familiar with databases like MySQL or Microsoft SQL Server. These fall under the category of Relational Database Management Systems or RDBMS, where data is stored much like a spreadsheet in rows and columns inside tables. These tables have a rigid structure, and we use a rather simple to understand interface called SQL to access or manipulate the data inside. RDBMS type of databases have been around for over 20 years now, so it's not anything new. Here's what a typical RDBMS like MySQL works like. You have tables with columns and rows. In this example, for instance, we have to fetch the phone number of a person by the name of Kevin Flynn. We can do so by using the SQL statement as shown here. The problem with RDBMS type of databases has to do with the data explosion that we are witnessing these days. Over the past 5 years, acquisition, processing, storage, and consumption of data has skyrocketed beyond our wildest imagination. Much of this is attributed to the fact that mobile is now at the forefront of the information revolution. There are millions of apps making billions of transactions to databases, storing, updating, and fetching data all the time. All of this has given rise to the term big data, which refers to storage and processing of extreme amounts of data. In a software as a service market, for instance, as the user base increases, so does the requirement for storing data. This is where a traditional database like MySQL can easily hit a brick wall. The rigid nature of RDBMS, coupled with the fact that it doesn't work well in a distributed environment, means that it is not exactly the best solution for handling extreme amounts of data. Additionally, data these days does not prefer being conformed into a fixed schema. And since an RDBMS requires you to have a fixed schema, it does not fit well into a flexible development environment. So, what is the solution? Well, there is no single solution, and the final practical solution is always a well-researched and experimented blend of various technologies that work for a given scenario. One of the best solutions out there is the new breed of NoSQL databases, out of which MongoDB shines like a bright star in the sky. Mongo, derived from the word humongous, is just that. It allows you to easily manage humongous amounts of data in a simple and efficient way. Instead of tables with rows and columns, MongoDB stores data in documents using key value pairs as shown here. This looks familiar, doesn't it? The format used by MongoDB to store is called BSON, which is similar to JSON and is used like JSON. But the real awesomeness is in the fact that MongoDB uses a flexible schema. Note the second and the third record have two different and unique key value pairs, one for the Skype ID and the other for the Twitter handle. These do not appear in the first and the last record. This means that we store what we want to store without worrying about a fixed table structure. If at any point my web application needs to store additional data for a user, I can do so directly, literally without making any changes to the structure or design of the database. I just add those new and extra key value pairs when storing data, and it just works naturally. In an RDBMS, it is a project and a mammoth task to modify an existing structure at a later stage in a production deployment, something that can potentially break a lot of things both in the database and in code. No such problems in MongoDB. Mongo also supports different kinds of data formats as well as structures. Here we see formats like numbers, strings, arrays, and even a one-to-one data structure where JavaScript object is stored as the value of a key. Now, in cases where a user might have more than one address, we simply add another object and it works. No need to create a separate table or a column for such cases. This is a one-to-many relationship that can be easily deployed in MongoDB. Every record in MongoDB gets a unique ID as well. Normally, developers have to resort to all sorts of techniques to generate unique identifiers, but Mongo takes care of it. So if you come from an SQL background, which typically I assume most of us do, then here's how MongoDB differs in terminology from its SQL counterparts. A database is still called a database in Mongo, while a table here is known as a collection, since tables need to have rigid structures, whereas the document nature of MongoDB means that you can have a flexible schema. Every row of data is called as a document, and every column is a field or a key that has a value attached to it. In terms of usage, here's a small snippet to whet your appetite. In SQL, we use the select statement to fetch columns from a table, and we can optionally use a where clause to filter down the records to those that match the filter. In Mongo, we use db.collectionname.find, and in the brackets we simply pass in an object with a given key value pair. This fetches us the rows that we want. Pretty simple, huh? One of the biggest strengths of MongoDB is in its ability to scale. This is one of the biggest reasons why Mongo or typical NoSQL databases are gaining popularity. In an RDBMS, scaling means upping the resources on the database server. In the case of MongoDB, when you need to scale, you simply add more servers. And you do not need supercomputer grade servers. These could be commodity machines. Through a process called sharding, MongoDB automatically distributes data across these machines to horizontally scale in an elegant and efficient manner. You can deploy MongoDB in one of two ways. You can either install it on your own server or cloud infrastructure, in which case you're the administrator responsible for deployment, maintenance, and scaling. Many startups these days do not have the bandwidth to deploy an expert on database servers, which is why a new breed of service providers known as database as a service providers have made deploying MongoDB a breeze. Companies like MongoLab and Compose.io allow you to deploy a scalable MongoDB database in absolutely no time. In this course, we will take a practical approach to using MongoDB in our projects, and we will use the services of the awesome mongolab.com. Using MongoDB with any language or platform is done by way of a driver interface. So for instance, with Node.js, we require a driver which provides us with an interface to MongoDB from within our Node.js code. There are many Node.js MongoDB drivers available out there, and we will lock down on the best solution in our upcoming project called ChatCat. When you install MongoDB, you also get an interactive shell interface known as Mongo. This is based on the same V8 engine as Node.js, so it feels exactly like the Node REPL interface. The Mongo shell is handy for playing with the database. Numerous GUI-based tools are also available for MongoDB, such as RoboMongo. You are free to try these out. So what are the benefits of MongoDB? Well, Mongo excels at reading and writing data at awesome speeds, which is perfect for modern day web apps and big data solutions. Mongo is very highly scalable with a high degree of availability. Scaling up means adding commodity level servers with no need for very specialized high-end hardware. MongoDB uses JSON style documents to store data that do not have a fixed schema, making it perfect for web apps and companies who want to flexibly grow with the times. And as with any other language, Mongo works brilliantly with Node.js as well. It is not surprising that MongoDB enjoys an amazing customer base, including big names like Forbes, Expedia, and MetLife. Companies that have to process millions of database transactions every day are actively using MongoDB and getting fantastic performance, stability, and scalability. Now in this course, we'll be using MongoDB through mongolab.com. MongoDB is a complete subject in itself that warrants its own dedicated course, and therefore it is only practical that we deploy a production-oriented solution rather than cooking up our own, which would tend to distract us completely from the subject of this course. We will therefore install MongoDB on our local machine to use the Mongo shell interface to play with the basic interface. However, we will still use mongolab.com for our production level deployments. We will also analyze two popular drivers or interfaces to Mongo in Node.js as mentioned earlier.